For this first example, we're going to have a sequence of numbers with a common difference. This is important. D is that common difference between two consecutive terms, two numbers. That's what they're talking about. It is constant. What I mean by it's constant, it's the same amount each time. Okay? So if it's constant, we're talking about the same amount each time. It cannot vary. It cannot change. Now, to get the next consecutive term, the next term in the sequence, you're going to have to add by the difference, by the D. All right, these are the parts to ways of writing an arithmetic sequence. We can do a subscript. Subscript means basically the variables on the bottom here. Okay, now the parts don't vary that much. The first a sub n, that always means the nth term, any number of term. I can say the term n is 5, so the fifth term. I can say a sub 11, that means the 11th term. Now, when I do n minus 1, yeah. So if I said, I'm talking about the 11th term, but if I do 11 minus 1, so that means n minus 1 is talking about the previous term. Okay? So if I subtract 1 from the term I'm talking about the one before it, the previous term.
And D is like a completely different term?
D represents our common difference.
Oh.
That represents the amount I'm adding each time to the term. Okay. So this is subscript notation. The parts pretty much mean the same. This is just function notation. So f of n is still going to be the nth term. N minus 1 is still going to be the previous term. And D is still going to be your common difference. Now here's the one that changes. This is your explicit sequence, or explicit form is usually where you have the formula. A sub n is still your nth term. But a subscript 1, that represents the first term in the sequence. And D is still your common difference.
So in the recursive function notation, are we going to be like multiplying? Does this parentheses?
Well, in this one here where the n minus 1, you're going to do that part first to get the term we're referring to, and then adding to D. So anytime we're talking about arithmetic, we're dealing with addition.
Oh, so the parentheses on the recursive function notation is addition?
No. Recursive is the n minus 1 here, the subscript.
Oh, I get it.
Yeah. All right, now, yeah, it's the same thing. If for a geometric sequence, it's a sequence of number in which you have a common ratio, R, between the consecutive terms, two consecutive. It's still constant, so it's still the same amount. But with geometric sequences, you are multiplying by R. So geometric is dealing with multiplication versus arithmetic is dealing with adding. Okay. All right, the parts are pretty much the same. The a sub n is still your nth term. N minus 1 is still the previous term. But now instead of D, we have a R, and that is your common ratio. That is the amount that you are multiplying to each time. We're not adding each time, we're multiplying each time. So in the explicit form for geometric, a sub 1 always represents the first term. And your R is your ratio. That's the amount you're multiplying to each term each time. It's got to be the same for it to be a sequence. It has to be constant. Okay, so the first three problems here, we have to determine if it's arithmetic, sequence, geometric, or neither. What I would do is I check arithmetic first, meaning is there an amount that I can add to get the next term? So like if I go to 2 to go to 4, is there an amount that I can give me that for?
2.
I can add 2. Okay, so for it to be arithmetic, I have to add the same amount.
So it has to be over the same.
So it's not.
So this one is not, because when I do 4 plus 2, that doesn't give me 8. Does that make sense?
So
Geometric, right?
Yep, so now it's geometric, yeah.
oh, arithmetic is
So what am I multiplying?
2
Times 2. And then if I do times 2 again, I get 8, right? And 8 times 2, sorry, I forgot that's showing.
So it's geometric. Because
Yeah.
It's multiplying.
Because it's multiplying each time. Alright, so this is geometric. I'm just going to abbreviate that, geo. And how did we know it's geometric? Because we multiplied by 2 to each term. Since it's the same amount each term, that means our R equals 2. This was a common ratio. All right. Let's try number 2. We got a negative 74, and then it changes to negative 49.
That's 25.
Plus 25. Okay, now I got to check that. There's a negative 24 plus 25.
Yes.
Give me negative 24.
So it's arithmetic because
Yeah.
it adds by.
Yeah, this is arithmetic because we are adding 25 to each term. We're adding the same amount as a constant addition each time.
And the next one is neither because it just doesn't make sense.
Yeah, this one is neither because there's nothing I can repeatedly add to get to the next term, and there's nothing I can repeatedly multiply. So yes, this is a neither. Okay. All right, so now that they're going to be giving us the parts to the sequence, either the common ratio or the common difference, and they want you to find the next 3 terms. So let me explain how this is broken down. Okay. This part, a sub n equals a sub n minus 3. This is the formula. Okay. This is our formula. Now, in the formula, there's some parts here. A sub n, that represents the nth term. Okay. Here where it says a sub n minus 1, this part here represents the previous number. For the previous term. And then because I see minus d here, minus 9, that is the d, which is the common difference. Oops. Our common difference that they're showing here is subtracting by 9 each time. Now, the a sub 1 right here, because it says there's a 1, that represents the first term. Okay?
So a sub 1 equals 18.
Yeah, so our first term is 18. So that's the first term. Then the difference is minus 9. So that means I'm going to subtract 9 from it, get the next term. That would be 9, right? Subtract 9 again, and that would be 0. So there is, they want you to find the first 3 terms. There's the first 3 terms. 18, 9, 0.
Oh, we just have to like solve it with the terms and then we find it.
Yeah.
Ooh. And the next one is a
Negative 9.
Yeah, the next term after that would be a negative 9. Yes.
because it's the negative.
Mhm, mhm. Okay, so here, this is the formula. Here's the parts you need to understand. Okay, the formula, like for an explicit one, I know this is geometric because there's multiplication taking place right here. All right, when I see that parentheses, that represents multiplication. So the way the formula looks, I'm just gonna write it above it. The formula always looks like this. It says a sub n equals a sub 1 times r, and then it'll have n minus 1. Okay, so that means a sub 1 is the first term. So in this example, a sub 1, that -5 represents the first term. That's our first number. Okay. Yeah, the r is the 2. The r is the 2. So that means we are multiplying times 2 to get the next term. -10. Then we're going to do it again. Times 2. -20. And there's our first 3 terms. How you get 9? I don't know. Alright, so do you figure out, can you figure out what type of sequence number 6 would be? Yeah, geometric, because again, there's multiplication happening right here.
By 2.
No, not by 2.
So 320.
What is the r in this one? What are they multiplying? Yeah, the r is 1/4.
So it would be 320 and a quarter of 320.
Yeah. So you start with 320 and take a fourth of that, yeah.
So understand.
Or divide by 4.
Yeah, so divide by 4. Yeah, exactly.
320 divided by
It's
4.
80.
Yep, that's 80.
And
And then take a fourth again. Yeah, no. So
Oh, dividing 80.
yeah.
Wait, so division is arithmetic?
What?
No, repeated division
Repeated division
is the same thing as multiplication.
multiplication, so it's geometric.
Yes. Okay. All right. So what would be the next term?
20.
Yep, 20. There's your first 3.
And it's on the
Huh?
calculator too, n of 1.
The f of 1, this represents the first term. That's why I started with 320.
And what about the n minus 4?
The n minus 1, that is the previous term.
Oh, so
Yeah. So you're taking a fourth of the previous one to get to the next one. All right. Now they want us to write the formula for the sequence. Okay. First, in order to write the formula, you have to know what type of sequence we have. So how are these numbers changing each time?
Plus 10. Minus 10.
Minus 10. Okay, so, oh, sorry. Minus 10. All right. That means we have a constant difference, which means our d equals -10. This is arithmetic. Okay, so here's the formula for an arithmetic sequence, an explicit formula. It is a sub n equals a sub 1
Plus e.
n minus 1 times d. Okay, so we're just going to plug in the parts to simplify the formula. We know a sub 1 represents the first term. What number is our first term?
-10.
No,
-7.
-17. So I'm going to write -17 plus my n minus 1. And what is our d?
-10.
Yeah, -10. All right, so please fix that part. Okay, so we're just going to simplify this formula, guys. We're just going to simplify by doing order of operation to our math. We're going to distribute the -10 to get rid of the parentheses. A -17 minus 10n plus 10, right? Negative times a negative is positive. And then we can combine like terms. We have a plus 10 and a -17. Yep, so our a sub n for any term would be a negative 10n minus 7. So think about that, right? For any term I'm trying to find, I'm going to plug this in. What does the n represent? What do you think this n in this formula represents?
Like an X, like a variable?
No, it's the term that you're trying to find. Okay, so let's think of this, right? We're going to find the third term. So if I'm going to find the third term, that is a sub 3, negative 10 times 3 minus 7. What is a negative 10 times 3 minus 7?
Negative 30.
Negative 30 minus 7. So it equals negative 37, right? What was our third term? Negative 37. So once we simplify it, we can find any term.
Oh, I get it.
So
Find any term using the numbers.
now that I have this formula, yeah, now that I simplified this, I can find any term in the sequence. So if I wanted to find the 100th term, I would just put 100 where the n is at, and then work it out. Okay. All right. So let's look at this next one, on number 8 here. How do you think these numbers are changing each time? Like, to me,
Minus 80?
No.
nah, they're getting big so fast. Times what? Yeah, times a negative 6. Like, to me, because it gets big so quickly, that has to be multiplication. So this is times a negative 6 times a negative 6 times a negative 6. That means r equals a negative 6. That's our common ratio. Yes. This is a geometric. Okay. The formula for geometric, the explicit formula, says a sub n equals a sub 1 times the ratio n minus 1 to the power n minus 1. A sub 1 is still the first term. So that is the 12.
12 parentheses.
Yep.
Negative 6.
Very good.
N minus 1.
Yes. Negative 6 to power n minus 1. And there, that is our formula.
Yeah, so we need n.
So if I need to find any term,
The first term, you just put 1.
1, and then yes,
minus 1.
exactly, yes, you just plug in the term you're trying to find for n. Okay. Now, first determine the type of sequence it is. We got a sub 3, the third term is 40, the fourth term is 60, and then the fifth term is 75. First find the pattern.
Plus 15.
Very good. Okay, so because it's plus 15 every time, yes, this is arithmetic. Meaning our d, our common difference,
It's 15.
is plus 15. Yes. Now, the formula for arithmetic is a sub n equals a sub 1 plus n minus 1 d. Okay, remember what the a sub 1 represents?
Yeah. The first term.
The first term. Okay, so do we have the first term?
No,
No.
because it's a sub 3.
Because it's a sub 3, right? So we have to go back. So think about that. If a sub 3,
Divide by 3, so it's 15.
So it would be.
what is a sub 2 gonna? Not 15.
Oh, we have to just find the first term.
A sub 2 would be 30. Then what a sub 1 would be 15.
Oh, I thought you could just divide by 3.
No, you can't divide by 3 because I'm adding 15 every time.
Yeah, that makes sense.
Okay. So now we
I have to
know.
do it the same way you guys.
Yeah. I'm just keeping the sequence. I see what you're saying.
Yeah.
Okay, because like repeated. I see what you're saying because you're doing repeated addition is like multiplication. Yes. Okay, you're doing the inverse. So now I know this is my first term, 15. So I'm putting 15 here for a sub 1 plus n minus 1, and what was our d?
15.
15. So we're just going to distribute.
So you got 15 plus 15 and minus 16. Wait,
Minus-
minus 15.
It's not
Yeah.
negative.
Because we add up 15 every time. Because that was plus 15. That's why the d is 15.
And if you combine like terms,
Yeah.
15 plus n. So After you get a sub n is equals 15 plus n. So 15n.
Equals 15n. Yes.
Oh, and if you put any of them because it's repeated addition, it's
Mm.
like multiplication.
Exactly what we were just talking about. Yes. Because we have repeated addition in our sequence, that would be showing like multiplication when we simplify it. Yes.
Yeah.
All right. So this goes in your spiral on the next page.
Yeah,
Okay. Put that in first.